We are going to be taking a look at solving rational and radical equations. If you don't remember what those words mean, rational are things that have ratios or fractions. And so you can imagine solving some proportions, right, where we would have to possibly cross multiply. And you can do that as long as there is one fraction on each side of the equation. That is always a technique we can use, right? It is also true about ratios that if I have a ratio that's equal to another ratio, like in this case, 2 divided by 1 is the same as 6 over 3. And we could also flip both of those fractions upside down. That is a possibility, okay? The proportion will remain true. So you may have to do that. Now, what would we have to do if there was several fractions on a single side, like in this case? Well, if that was the case, then you would have to find a way to combine these two fractions into one, or maybe you move this one to the other side. Those are two possibilities, but you cannot do the cross products until there is a single fraction on each side. Okay? Now, as far as radicals are concerned, those are things with roots. So you could have square roots, you could have cubed roots, or any other roots, fourth or fifth roots. And if you are trying to get rid of a square root, right, so let's say I've got the square root of x is equal to 10, I would solve that equation by squaring both sides, because an exponent of 2 and a root of 2 cancel each other out. So, in a similar fashion, if I have a cubed root that is equal to a number, you want to cube both sides of that equation. Okay? Now I have 6 examples for us to go through, and you may have to pause or rewind a couple of them to hear them a couple times, right? Here we go. So here's our first one. We have two fractions, and they're added together, and it's equal to 0. Okay? So I could try to add these fractions together and, try that stuff, but I think what I'd do instead is I'm going to add this fraction to the other side. All right, that will make it negative, and that's okay. So let's see what we get. X minus 8 over 3 equals negative x minus 3 over 2. Now, that negative, because it's there because we subtracted this fraction, we could distribute it through the parentheses, and I think that's what I'm going to do next, right? We're just playing with this to see what happens. There's a lot of different paths that we can take, and this is the one that I've decided on taking. So if I distribute the negative through those parentheses, I'll get negative x plus 3 over 2. And at this point, I notice I have a single fraction on each side. So I could cross multiply, right? I'm allowed to do that. That's the cross product property you learned back in junior high. And so if we do that, we will have 2 times x minus 8. And in the other direction, we will have 3 times negative x plus 3. All right? And now that requires us to do the distributive property. So 2 times x and 2 times negative 8. And then on the other side, we have 3 times negative x and 3 times 3. All right, so now I have no more fractions. I've got no more parentheses, and now I just need to move things around, right? This is pretty easy stuff. Now we're going to take these negative 3x's and add them to the other side. That'll give us a total of 5x's on that side. And then I can add this 16 to the other side there, and that'll leave me with 5x equals 25. And then if I divide both sides by 5, divide by 5, I get 5, right? So there is my solution. X is equal to 5. All right? Now you may have tried something different. I don't know if it would have been longer or shorter had I just tried to put these two fractions together. All right? There's a lot of different techniques that you can use. There's even a technique to get rid of the fractions right off the bat. Okay? All right, let's try another example. And this one, okay. So this one's a very unique case. Look at the denominator for each side. They're exactly the same, all right? And so if I had a situation, let's say I've got this situation where x over 2 is equal to 7 over 2, and we use our cross product property, right? We would end up with 2x equals 14, and then I'd have to divide by 2. And look at that, we're back at 7, right? And kind of a no-brainer that if the denominators are the same, then the numerators would have to be the same, okay? And that's kind of what we're going to use on this one, right? Because our denominators are automatically the same, so I know that my numerators will also have to be the same. So I know that x squared has to be equal to 9, and to solve that, I would square root both sides, and that would give me x equals plus or minus 3. Remember, I told you that if you introduce the square root into the problem, you have to put plus or minus, okay? But, okay, here we go. There's a big but on this one. Check out my denominator. What happens if I plug those answers in? Can I do that? Will it work out if I plug a 3 in there? 3 minus 3? That's 0. That's on the denominator. We can't use positive 3. We can only use negative 3. Negative 3 is the only solution because the other value that we came up with is an excluded value, right? Remember talking about those excluded values? Okay, so in this example, only negative 3 is the correct answer. Okay, this one looks a lot harder, but there are some things that are similar among these items. The first thing I would do is I would look for any similarities, and to do that you kind of have to factor all of these parts, all right? So this first denominator has a greatest common factor of 3. I can take the 3 out. The second denominator is a difference of 2 squares, so that would be x plus 2 and x minus 2. And then the last denominator is just x minus 2. Can't factor that at all. And so you can see that in the first two, they share something in common. In the last two, they also share something in common. And if I wanted to make them all the same, what I could do is fill in the missing parts. So like, for example, on this first fraction, I could multiply by x minus 2 over x minus 2. And on this second fraction, I could multiply by 3 over 3, right? That fraction is equal to 1. And on the last fraction, I can multiply it by 3 and x plus 2. Top and bottom, 3 and x plus 2. If we do this, then we are going to get a common denominator all the way across. Okay, so let's see what happens. So in this first one, we're going to have to distribute 2x and minus 4 there. All right, and on the second one, we'll just end up with 3 times 1, which is 3. And on the last one, we're going to have to multiply 4 times 3 and x plus 2. So that's 12x and 24. Okay, and then of course all the denominators are the same. And since they're the same, right, like I said in the last example, you can, if the denominators are the same, the numerators are the same. So we can actually ignore those for the time being, right? We still have to keep in mind there are some excluded values, namely 2 and negative 2, but if we don't get those in the end, we'll be okay. So let's go ahead and just keep on working from here. So simplify this out. 2x minus 1 equals 12x plus 24. Okay, scroll this down a little bit. All right, we can, let's see what we can do. We can subtract these 2 x's to that side of the equation. That'll give us 10 x's plus 24. And then we can subtract 24 from both sides of the equation. That'll be negative 25 equals 10x. And then the last thing we need to do is divide by 10. All right, so negative 25 divided by 10 is negative 2.5. All right, and that wasn't one of my excluded values, right? Because remember, our excluded values were 2 and negative 2 because of how we factored it. And so this one is okay. All right. It's pretty interesting how that one worked out. Okay, now on to radicals. The first thing you want to do is make sure your radical part is isolated by itself. In this case, it already is, right? So all I really need to do now is square both sides, and that will yield us just 3x plus 1 equals 16, right? When you square something that's square rooted, those cancel each other out. All right, so now what do? We subtract the 1 from both sides of the equation. That'll give us 15. And last step, if we divide by 3, 15 divided by 3 is 5. Okay? Now with these, you definitely want to plug it back in and double check to make sure it works. Okay? Because on the last kind of problems where we had fractions, we kept in the excluded values in the back of our mind, and we were always kind of double checking those. Here, there are some values that we're not allowed to plug in, right? Because our answer to this square root part was a positive 4, which means the part underneath it has to be positive. It can't give us anything negative. So let's just plug it in and double check it. So 3 times our 5 plus 1, that is the square root of 16, which is 4. Okay, so this one checks out. All right, next problem. Remember what I said about radicals. You want to make sure it's isolated by itself on one side of the equation. So in this case, we need to move this 5 to the other side of the equation, and we do that by subtracting it. And that way our square root is all by itself. All right. And now when we square both sides, make sure you square both sides. Look how I wrote this one. I'm using parentheses. I have to square, or I have to multiply the x minus 5 times itself, and that means you have to FOIL it, right? You have to FOIL it. On the left side of the equation, the symbols just cancel each other out. The square root and the squared, gone, right? They're opposites. But on the other side, you have to multiply the x minus 5 times itself, and the result of that is going to be x squared minus 10x plus 25. The negative 10x is from the inside and the outside terms combining together. Okay? And so now we have a quadratic equation, which we just learned about how solving. It's very important to solve quadratic equations by getting the 0 on one side of the equation to start with. So we are going to start by moving the 7 and moving the x to the other sides of this equation. We're going to subtract both of them. That's going to give me an x squared minus 11x plus 18, I believe, right? 25 minus 7 is 18. And now we have options, right? I've got different ways that I can solve this one. The first thing I'm going to think about, is it factorable? Can I factor this equation? Are there any numbers that multiply to be 18 that also add up to be negative 11? And I think negative 2 times negative 9 is just the pair of numbers that I need. All right, so we're going to have to factor this. And if you couldn't think of that, then you can always solve it on your graphing calculator. But I'm going to go ahead and factor it because these are nice and neat factors. Negative 2 and negative 9, there is my values. And then we can set each factor equal to 0 and solve them independent of each other. So this one will give me 2, and this one will give me 9. And we're not done there, right? We have to make sure these answers work. So we're going to plug them back in and see. We're going to go way back up to the original equation, and we're going to see if 2 and 9 actually work. Okay? All right, so let's try it out. 5 plus the square root of 2 plus 7 equals 2. Wow, I can already see that's not going to work because that's 5 plus the square root of 9, and the square root of 9 is 3, and 5 plus 3 is 8. How in the world is that 2? So this does not work. All right, big old X on that one. All right, let's try the other side. Hopefully it works. 5 plus the square root of 9 plus 7 equals 9. And what is 9 plus 7? 9 plus 7 is 16. The square root of 16 is 4. Add those together. 5 plus 4 is 9. Hey, look at that. It worked itself out, all right? So we have one value that works and one value that doesn't. So we're going to keep this one. And this one, nope, this is what we call an extraneous solution. All right? Extraneous solutions are those we get legitimately through our algebra process, but they don't actually work. Okay, so make sure you double check your answers. All right, let's try one more, a super tough one. On these type, I would actually suggest using your graphing calculator, okay? So I'm going to pull up mine. I mean, we could do it algebraically. There's a lot involved, but it's probably just easier to solve this graphically. And since we're supposed to be masters of our graphing calculator, let's go ahead and try it out. Move this over here. Okay. So this is what we want to do. We want to take one side of our equation. Yeah, that was pretty bad there. We want to take one side of our equation here and type that into the calculator as y1 and the other side in as y2. Okay? And so that's going to be, I'm going to hit the y equal button, and I'm going to type in square root of x minus 3, and then plus the square root of x plus 5. And then on the other, the y2 part, I'll just type in the number 4. Okay, so the number 4 is just going to be a horizontal line through the y-axis at 4. No slope or anything like that. And then the square root thing, it's probably going to have some kind of curve to it. We need to find out when these two things are equal to each other. Okay, so we already talked about what these square root functions look like. That is a curve that is just going upward like this. Okay, it won't come back down. But we need to find this point of intersection right there. All right, and we can do that using our calculate menu. So second and trace, and check out option number 5, the intersection of two curves. All right, the questions are a little different. Check out the bottom here. It says the first curve, and it has y1 written at the top of my screen. So I'm just going to hit enter. Enter. I got a little lag on my calculator here. Enter. Maybe, maybe not. Okay, there we go. First curve. Enter. It is not wanting to click. Just a moment. All right, let's see if it'll work this time. Enter. Enter. Oh, good Lord. I guess I need to be on the curve somewhere. Let's try that. Enter. Hey, there we go. And enter, second curve, and now take a guess. All right, so lesson learned there. When you're trying to hit enter on this calculator, you need to be able to see the blinking cursor. Okay, so it looks like the point of intersection is when x is equal to 4. When x is equal to 4, and that is the solution. X is equal to 4. You can plug it back in to check it out. It will work, right? 4 minus 3 is 1, so we have the square root of 1. Come on, square root of 1. And then on the other side, 4 plus 5 is 9, so that's the square root of 9. And that does equal 4 on the other side, right? So calculator, type it in, use your calculate feature menu. Option 5 is for the intersection, and that should make it super easy on those, okay? You could try to do it algebraically, but it's going to be a lot longer than this other one that we did, okay? Try that at your own risk. Okay, have a good day. Bye.